This video is over chapters 8, 9, and 10. Chapter 8 is over the waves. Some things that I've learned is that there are two families of force that influences waves. They are generating forces and restoring forces. Generating forces are those responsible for creating a disturbance on the water surface. Restoring forces are those responsible for returning the water surface to an undisturbed state. The most common generating force for water is waves as wind. These wrinkles are small waves called ripples or capillary waves. The restoring force for these small capillary waves is the surface tension of the water. Common wind generating gravity waves can be divided into two types based on the depth of the water they travel and compared to the wavelength: deep water waves or shallow water waves. Deep water waves travel in water deeper than one-half their wavelength. Shallow water wave travels in water shallower than 1/20th of their wavelength. There are many different terms to call waves. The crest is the part of the wave that is depressed the lowest below the undisturbed sea surface. Trough is the part of the wave that is depressed in the lowest below the undisturbed sea surface. Wavelength is the shortest part of the waveform that is repeated multiple times will produce the wave shape. The wave height is the vertical distance from the elevation of the crest to depth of the trough. The wave's energy is present as potential energy due to the changing in elevation of the water surface, and as kinetic energy due to the motion of the water particles in their orbits. The higher the wave, the larger the diameter of the water particle orbit, and the greater the speed of the orbiting particles. Therefore, the greater the kinetic and the potential energy. The maximum value is determined by the ratio of the wave's height to the wavelength and the measurement of the steepness of the waves, which is the highest height divided by the length equals the steepness. Some things that I found interesting is that the diffraction is caused by the spread of the wave energy sideways to the direction of the wave of the travel. The surf zone is a shallow area along the coast in which the waves slow rapidly, steepen and break and disappear in the unturbulence and spray of the expended energy. What I want to learn more about is the sudden movement in Earth's crust may produce semi-seismic sea waves or tsunami. I would like to know more about tsunamis in general. A question I have for this chapter is, in the wave speed, how do you find out the length of the wave in its wave period to determine the speed? Like, how are you able to measure the wave, the length of the wave? On chapter 9, it talked about tides. Some things that I've learned is that tidal currents may be extremely swift and dangerous as they move water into the region on the flood tide and out of the region on the ebb tide. In a large ocean basin, the tide wave moving across the sea surface is a shallow water as a progressive tide. Some examples of these are the Western North Pacific, Eastern South Pacific, and South Atlantic Ocean. The tide wave speed is a free wave moving across the water surface is determined by the depth of the water. Something I found interesting is that when a tide wave moves as a forced wave, that is the result of the moon's attraction force and the Earth's rotation. What I want to learn more about is about tidal currents and how they become so dangerous. I've had this experience where my sister almost got swept away by a tide, and so I would like to know how they gain up that energy to sweep away things. The question I have for this chapter is, how does waves determine the Earth's rotation? I just found that striking. Chapter 10 talks about coasts, beaches, and estuaries. What I've learned is that the term coast, coastal area, and coastal zone are used to describe these land edges that border the sea, including areas of the cliffs, dunes, beaches, bays, coves, and river mouths. The shore is part of the coast. It is the region from the outer limit of the wave action on the bottom line of the wave's direct influence on the land. The beach is an accumulation of sediments that occupies the portion of the shore. The beach is not static, but moving and dynamic, because the beach sediments are constantly being moved by seaward, landward, and along the shore by near shore's waves and current action. The beach includes the sand and sediments lying along the shore and sediments that carried along the shore in the near shore currents. What I found interesting is during the last period of the glaciation, sea level dropped an estimate 100 meters or more due to the storage of water on the land as glacier ice and the cooling subsequent decreased in the volume of the remaining water in the ocean basin. Approximately 3.8 billion people, which is about 60% of the world's population, live within a 60-mile radius of the coastline. In the United States today, over one half of the population lives within 50 miles of the coast. What I want to learn more about is why bays are located near 30 degrees north and 30 degrees south latitude. A question I have for this chapter is, I know many people love the beach, including me, but why are we so attracted to it? I mean, it's just sand and then water. This concludes chapters 8, 9, and 10.